So, similar shapes, what are they? Okay, well, they're the same shape, okay, but just with a different size. Okay, same shape, different size. Okay, and there's three rules that help you determine if these are the same shape. Okay, rule one, if they have the same angles, right? So let's look at a triangle. Okay, if all three angles are the same, and then let's look at this shape here. All three angles are the same, then they are a similar shape. Okay, now similar shapes, same shape, different sizes, all about being enlarged or shrunk. Okay, it's the same shape, but it's just been made smaller or bigger. Okay, and this next rule is to do with that. So if you have a look at the side lengths, so 2, 4, and 6, okay, if they share a scale factor, all right, what does that mean? Well, here every side length has been timesed by 2. Okay, so here our scale factor is 2. Alright, so if all sides are proportional, okay, which means they're sharing the scale factor, then they are similar shapes. Okay, rule 3 is now this sandwich kind of rule. Okay, like side, angle, side in our congruent shapes, this is very, very, very similar. Okay, so if we have two shapes, okay, and they have, let's say, 6 and 7, okay, if they share the same, let's make this big, share the same angle, okay, and then their sides have the scale factor. Okay, so here we've got times by 2 again, here we've got times by 2. Okay, but the angle between them are the same. Okay, so side, angle, side, these sides need to have the scale factor and your angle between is the same. Okay, so those are your three rules that you're looking for when you're saying if two shapes are similar or not. Okay, let's look at some examples. So let's pretend you've got two parallel lines, okay, and then now we've got these two straight lines going through here. Okay, and let's label these A, B, origin, C, D. Okay, we need to see if these two triangles that we've made are similar or not. Okay, now firstly, parallel lines, got to think of our parallel rules. What do we know about these? And hopefully what jumps to mind is our Z angle. Okay, so this angle here and this angle are going to be the same due to this Z angle here. And then due to this other Z angle here, we're going to have this angle and this angle the same. Okay, then another rule we have is alternate or vertically opposite angles. Okay, so as these two angles are vertically opposite, then they're the same. Okay, and here you can see we've done angle, angle, angle. So because these two triangles share the same three angles, then they must be similar. Okay, perfect. Next example. Okay, it's used to find a length. Okay, so let's look at this triangle. So we have our triangle and we're told some points on our triangle. Okay, so this length here is going to be BC and this is parallel to DE, and then we got A here. Okay, so AB is going to be 20, BC is going to be 12, and DE is going to be 80. Okay, and you're told that triangle DAE and BCA are similar. Okay, so your inside triangle is similar to your big outside triangle. Okay, what does this mean? Well, because they're similar, okay, their side lengths must share this scale factor. Okay, as similar, we have this proportion. Okay, proportion means they're sharing the scale factor. Okay, so if you were to think of this shape and you were to enlarge it to get it bigger, okay, this would move kind of here. It'd cover up 12 and then it needs to cover up some more. Okay, so 12 times what gives us our 18. Okay, so we need to figure out our scale factor. We've got 12 times something is our 18. Okay, divide both sides, 18 over 12, divide by 6, so 3 over 2. So our scale factor is 3 over 2. Okay, so this length 20 on BA then gets times by 3 over 2 to give us our length DA. Okay, so then this means that DA is 20 times 3 over 2, which is 60 over 2, which is 30. Okay, and my question then to you will be find length DB. Okay, so you want to find this length here. So DB is then going to be, well, we know that this DA is 30, so then DB is going to be 10. And that is our similar shapes.